All right, ladies and gentlemen, we're going to dive into Chapter 11.8. This is our last section. It's called Linear Programming, and that's our goals for today is to use system of inequalities to solve those linear programming application problems. So this is going to answer that, when would I ever use this? Okay, so when I take a look, what is linear programming? It says it's an important application of mathematics. Linear programming is a real-world application using systems of inequalities to find maximum values like profits or minimum values like costs for a linear function. In its early development in the United States Air Force used linear programming to solve problems that involved allocating supplies to troops during World War II. So that's kind of neat. Allowed us to beat those Nazis, right? So we take a look at the next one. It says we are already linear programmers. We already know how to graph a system of inequalities, and now let's apply our graphs to some real world situations. So we're going to start you guys off with baby steps. We got a little vocab here. The first thing we have is inequalities are now called constraints. These are restrictions or constraints, okay? You might hear me say the shaded region, or now this might be called the feasible region. Okay, feasible means a possibility. This is an area where it's possible or feasible. And then last but not least, it says there will be a blank to test for a maximum or minimum value using the vertices of the feasible region. Okay, and the blank here is objective function. So there's going to be an equation that we're going to need to check. Okay, and we want to either maximize or minimize it depending on what we're looking at. Okay, so when we take a look at number one, it says maximize z equals x plus 3y subject to these constraints. Okay, so this right here, guys, is my objective function. We want to maximize that. Okay, now we don't use that until the very end, so we'll come back to that. So the first thing I notice is I've got all of these constraints or inequalities, and I want to go ahead and graph those. So I've got x plus y is greater than or equal to 3. I'm going to go ahead and subtract that x over, and I've got y is greater than or equal to negative x plus 3. Okay, reminder yesterday, if anytime you divide by a negative, make sure you switch that inequality sign. We just subtract it over so I don't have to worry about that. Okay, so I'm going to go ahead and graph that. I'm going to put my pencil on the B, so I'm going to go up 1, 2, 3. It's not hard, you see. Man, we're having fun. Now it's time for Rise Over Run. Then we go, we will graph you. All right, so we go down 1 over 1, down 1 over 1. I usually go all the way to the x-axis when I graph it. Okay, straight edges are nice. If you got them, I'll take my ID and use that. Okay, it's equal to, so it's going to be a solid line. So greater than or equal to. Okay, right now I would be shading above this line. I'd be shading up here. Okay, so I work towards the next one. The next one I got is x is less than or equal to 5. We know that's a vertical line, so I'm going to count over on the x-axis. 1, 2, 3, 4, 5, and I'm going to graph that guy. It's less than or equal to. Less than is to the left, so right now I'm shading this direction here. Okay. So right now I'm in this vicinity where the black and blue are overlapping. The next one I've got is y is less than or equal to 7. We know that's a horizontal line. So I'm going to count up 1, 2, 3, 4, 5, 6, 7. And I'm going to draw that horizontal line going across. Okay, it's less than or equal to, so it's solid and it's shaded down. So right now all my overlap is happening here. The last ones I have are your restraints of keeping this in the first quadrant. I have x is greater than or equal to 0. Okay, so that puts me to the right of this y-axis. So x is greater than or equal to 0. X equals 0 is the y-axis. And it's to the right, greater than, so it's shaded over here. And then last but not least, I have y is greater than or equal to 0. This one is the x-axis, and it's shaded up. So when I look at all the overlap where the black, blue, green, orange, and purple all overlap, that would be happening in quadrant 1, all right here. Okay, so this is my feasible region. Okay. And again, these two, I always say that's in quadrant 1. That's making sure everything is positive. Okay. So now what we have to do is we need to go around and find these corner points. Okay. So I need to find the intersections. Okay. If I take a look, there is 1, 2, 3, 4, 5 sides, which means there's 5 vertices. So this is a goofy looking pentagon that I gotta find these corner points. So I count over 1, 2, 3. So that's 3, 0. I count over 3, 4, 5. That's 5, 0. This one is up 1, 2, 3. So that's 0, 3. Big mistakes is people count and make silly mistakes on the x and y axis. So watch out. And then this one is at 7. So 0, 7. And then this one is over 5, up 7. So that's 5, 7. So now that we have the corner points of our feasible region, our shaded region, now we're going to take these guys and we're going to plug it into this objective function. Okay. Now, all of these points are to be considered, but only the corner points are going to maximize, give you the biggest value for this guy. Okay. So this is what I do. I go around the horn and I'll plug in 3, 0. Okay, so anywhere there's an x, I'm plugging in 3, and anywhere there's a y, I'm plugging in 0. So I got 3 times 0 is 0, and then plus 3 is 3. Okay, so right now he's winning. And then now I'm going to plug in 5, 0. Again, we're trying to find the biggest one. So I plug in 5 plus 3 times 0, and that ends up to be 5. Okay, so we do the next one. 5, 7. So I plug in 5 for x. Plug in 7 for y. And 3 times 7 is 21, plus 5 is 26. And then you can plug in 0, 7. Plug in 0 for x. 7 for y, and that gives me 21. And then last but not least, I'm plugging in 0, 3. So 0 for x plus 3 times 3, and I get 9 there. Well, they want us to maximize this. We want the biggest one. So my answer would be this one right here. Okay, so 5, 7 gives me the largest value, which is 26. Now, if they asked me to minimize it, if they said minimize, then the answer would be right there. Okay, my answer would be 3, 0 minimizes. It gives me the smallest value. But the question was maximize. That's our maximum. Okay. All right, so that was just a baby step 1, and now here's where it gets exciting. This is the application, right? So maybe you're going to be a farmer when you grow up. Who knows? All right, so here we go. We got a farming example. It says a farmer has 240 acres of land to plant his crops of corn and oats. Okay, at harvest time, he can make $40 per acre of corn and $30 per acre for oats. The farmer only has 320 hours of labor available to harvest this crop. To harvest corn, it requires 2 hours of labor per acre, and to harvest oats, it requires only 1 hour. So it says, how many acres of each crop should the farmer plant to maximize his profits here? So we're going to break this down into 5 easy steps for us. Number 1, we got to define our variables. Okay, so I always use x and y because we're using an x and y coordinate system. You know, x and y axis, it just makes it easy to graph it. So the first thing is x is going to be the number of crops that we have. Okay, so in this case, the first crop I see is corn. So this is the number of acres of corn. Okay. All right. So that's going to be your X value. And then Y is the next type of crop we have, which is oats. So this is going to be the number of acres of oats. Okay. So that's going to be my Y. The next thing says, write the linear function that helps us calculate the maximum profit of the farmer. Okay, again, if we're talking about profit, we want to maximize it. If they're talking about cost, you want to be minimizing that. Okay, so it says up here, at harvest time, he can make $40 per acre of corn and $30 for oats. So I'm going to put 40 here and 30 here. So if I make my equation, profit is equal to 40 times X. So 40 times the number of acres of corn plus 30 times the number of acres of oats, which is Y. And that is my objective function. I get 40x plus 30y. Now we come to our constraints. Okay, so step 3, identify the inequalities or constraints that represent the limitations of specific conditions. Okay, that must take place. So again, we got X and Y for corn and oats. Okay, and we got to take a look at what are our restraints. Now, I always remember that there's some common sense ones. There's, hey, we can't have a negative amount. So I always remember, hey, X has got to be greater or equal to 0, and Y has got to be greater or equal to 0. Okay. And then we talk about overall acreage that we have. Okay. So if I take a look, the total acreage we have is 240. So farmer has 240 acres to plant crops of corn and oats. So if I take the number of acres of corn and I take the number of acres of oats and I add them together, I can't go past 240 acres. I just don't have enough land. So that has to be less than or equal to 240. So as I take a look, the farmer only has 320 hours of labor available to harvest these crops. And it takes 2 hours for corn and it takes 1 hour for oats. Well, that's per acre. So that's 2x plus 1y or y, and he only has 320 hours. He can't go over that, so that's less than or equal to 320. Okay, so again, we can't have negative amounts of acreage. That's just crazy, right? And then we have our total acreage and the total amount of hours available. Okay, now we're going to graph this on a coordinate system, and when I graph it, I want it to look like y equals mx plus b. So when I do that, I'm going to subtract this x over for this blue one. And what I'm going to get is I'm going to get y is less than or equal to negative x plus 240. I'm going to do the same thing for this orange one. I'm going to subtract this 2x over. And now I've got y is less than or equal to negative 2x plus 320. Okay. So far, so good. So I really have 4 constraints. I have these 2. And then I also have that we're in the first quadrant. Okay, so everything's going to be positive. When I look at this, I usually just focus in on the first quadrant. So if you're looking at this graph, okay, this is my y-axis, this is my x-axis, okay? So this is putting me in Q1. So we want to graph these constraints, and then we want to find these corner regions, all right? So x is greater than or equal to 0. Again, we got a nice line here, shaded to the right. Y is greater than or equal to 0. Again, that put us in the first quadrant. Now, if I take a look, I've got to graph this thing up to 240, and I can't count by ones. That's just not going to work. All right, so I take a look. If I count by 20s, I should be able to get 240 in. Okay, now here's the key. If you're counting up and down by 20, that means you need to count left and right by 20. If you don't, then your slope will be incorrect. So make sure whatever you count up and down, you're counting side to side. Okay, so again, I'm going to count up 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. And then I'm going 240, so 20, 40, that's 240 right there. Okay, so I'm going to again count over 20, 40, 60, 80, 100 for X, 20, 40, 60, 80, 200, and so on and so forth. We'll add more tick marks as needed. Okay, so again, Y is oats. So I got oats here, and then over here we've got corn. So I'm going to go ahead and graph this guy. I put my pencil on the B, which is 240, and then I go down 1 over 1, down 1 over 1, down 1 over 1, and I usually do my slope until I hit the x-axis. Okay, and that takes me to 240 right there. Okay, again, straight edges are nice. And take a look and graph that guy right there. It's less than or equal to, so it's a solid line, and I'm shading down. So right now, I'm in this little triangle here when I'm shading down. So now I want to do the next one. Okay, so I got Y is less than or equal to negative 2x plus 320. So I'm going to count up to 320, so 240, 60, 80, 300, and then 320 would be right there. And now from B, I'm going to go down 2 over 1 for my slope. My slope is negative 2 over 1. Down 2 over 1. Down 2 over 1. Down 2. Man, this is fun. Down 2 over 1. I always go right until I hit the x-axis to make a nice, accurate graph here. Okay? So, connect the dots. Ends right there. It's less than or equal to. So that means this one is also shaded down. So it's got to be below the orange and blue lines. Okay, so if I look at my final answer for my feasible region, that's all right here. Okay, I got my feasible region right there. And now corner points, I've got 0, 0. That's not going to maximize profit. I got this point right here. That is 0, 240. I've got this corner point right here, which is 100, 20, 40, 60. So I got 160, 0. And then this guy right here. Okay. A lot of times that's going to be a nice, pretty point, but if you can't tell what that is, you could graph these two in your calculator and find the intersection. Okay, so you got lots of ways to find that intersection, but again, this one looks pretty nice. It's over 20, 40, 60, 80, and then up 20, 40, 60, 81, 20, 40, 60. So I have over 80 and then up to 160. Okay, so that's 80, 160. So I have 4 corner points. This is a 4-sided shape. We call that a quadrilateral. All right, so that means it has 4 vertices. Well, what I need to do now is I need to take these values here and plug it into my profit function. So again, I'm plugging those guys into P equals 40x plus 30y to see which one gives me the biggest amount. Okay, so I'm going to plug in 0, 0. We know 40 times 0 is 0, 30 times 0 is 0. I'm not going to make any money if I don't plan anything, so that's going to be $0 bucks. Okay, then I'm going to plug in 160, 0. Okay, so if I plug in 160, I got 40 times 160 plus 30 times 0. So I got 40 times 160, and I got 6,400. Okay. I'm going to do the other ones over here in orange. I'm going to plug in 80, 160. So my profit for 80 and 160, I'm going to plug that in. So 40 times 80 plus 30 times 160. Okay, so my calculator, I'm just typing that in. I got 40 times 80 plus 30 times 160 and see what I get. I got 8,000 bucks. Okay. Now these numbers are scaled back, so it makes it easy for us to compute this stuff. Obviously, it would be way more than that in real life. And then let's look at the last one. I got 0, 240. Okay, so 40 times 0, and then plus 30 times 240. And now we're going to see which one gives us the most. So 40 times 0 is 0. 30 times 240, I got 7,200. Okay. Now again, we're trying to maximize our profit. So we look to see which one gives us the best offer. Okay, and as I take a look, the best one is right here. Okay, this is the one. This guy right here maximizes our profit. So this guy, 80, 160 is our final solution. Okay, that's our max. Okay, so linear programming is, again, an application of inequalities, solving inequalities graphically. This allows us to, again, maximize or minimize whatever that objective function is. Okay, guys, we have a worksheet and a My Math Lab assignment the next 2 days, so you guys can get started with that, and I'll be back the next day. Have a great day.